All right, so we have the conservation of energy, and if you recall from class, we've got the original energy, which is our E naught, and we've got our final energy, E final, and we said that it's conserved, so it doesn't change unless work is added in, which is our W. So then we get that our original energy plus work gives us our final energy. So now work can only be done on a system by an external force. So it's not something in the system that's going to make the energy increase or decrease. It's something from the outside. So for example, we've got these people pushing on the plane. They are the external force pushing and making the energy of the plane increase as it moves. So the equation we're going to use is work equals force, which is our F, times distance, which is our D, and it's parallel, so that means in the direction of movement. So if the object doesn't move, if the distance and displacement doesn't change, then there's no work done. So then if the distance doesn't change, then work equals 0. Because if you think about it, work equals force times distance. If this is 0, then 0 times F is going to give you 0. If it's negative work, so now if the displacement is in the opposite direction of the force, that means our displacement is going to be negative, which is going to give us negative work. It's going to take energy out. It's going to be subtracting. Likewise, if it's positive, if it's going in the same direction, it's going to increase. So if you think about it, if you are running and someone starts pushing you from behind, you're going to go faster. The units for work and energy are the joule, which is equal to the Newton meter, which is equal to the kilogram meter squared divided by second squared. The one you need to remember is joule. And since that's the unit of work, it's also the unit of energy because they add together. And James Joule is the one that the joule is named after. So now we have an example problem. We've got a 24 Newton force and it's positive, so our F equals 24. Is applied to an object that moves 10 meters in the same direction. So that means our D is 10, and it's positive since it's in the same direction. So they want to know about the work. So we've got work equals force times distance, which means work equals 24 times 10, which gives us 240 joules. So now next we've got, again, a 24 Newton force, but this time it's saying that the object moves 10 meters in the opposite direction. So we've got our force still equals 24, but now our D equals negative 10 because it's in the opposite direction. So now when we multiply, we are going to get a negative answer because we've got positive 24 times negative 10. So now our work is going to be negative 240 joules. Now again, we've got our 24 Newton force, but now it says it's stationary. Remember, when something's stationary, it does not move. So our D equals 0, which we said before means that our work equals 0 joules. How much force must be applied to an object such that it gains 100 joules of energy over a distance of 20 meters? So now they're giving us our work is 100, our D is 20, and they want to know what F equals. So if we have W equals F times D, if we divide by D to get F by itself, now we've got force equals work divided by distance, which is 100 divided by 20. So our force equals 5 newtons. Next, they want to know distance. They're giving us our force is 400. An object that gains 1600 joules of energy, so our work is 1600. So again, work equals force times distance. This time we're dividing by F to get the D by itself. So now we've got D equals W over F, which gives us 1600 over 400. So now our D equals 4 meters. Number 6, a girl pulls a sled at a constant speed of 1.2 meters per second by applying a force of 350 newtons. So our force is 350 newtons. How much work will be done during 100 seconds? So we know our T is 100, and we're looking for work. So we know work equals force times distance, and the given that we're missing is our D. But we're given speed and we're given time, and if we recall, speed equals distance over time. So to get D, we're going to use that equation. So to get D by itself, we multiply by T on both sides. So now we have D equals 1.2 times 100, which is going to give us 120. So now we can do our work equals force times distance, which gives us 350 times 120. So now our work is going to equal 42,000 joules. A book is held at a height of 2 meters for 20 seconds. Keyword here, held. That means our distance does not change. So our D is 0. Just because it gives a starting height doesn't mean that it's changing. So if our distance is 0 and work equals force times distance, that means our W also equals 0. A barbell of mass M is lifted vertically upwards at a constant velocity to a distance h by an outside force. How much work does that outside force do on the barbell? So if we have our free body diagram, we've got mg down. We've got that force applied up, lifting it up. Okay, so if we made it force applied minus mg, because that's positive and that's negative, equals, if we look, our A, if it's constant velocity, our A is 0. So that means it equals 0, because MA, anything times that 0 is going to be 0. So now to get force by itself, we would add mg to both sides. So now our force applied equals mg. So if we look, work equals force times distance. If we look over here, our force equals mg, so we can replace F with mg. And back in the problem, it says our distance is h. So our work equals mgh. Gravitational potential energy, if you look, this is what we just did. So we said our work is going to equal mass times gravity times h. So we know in general that the original energy plus work gives us the final energy. If our barbell had no energy to begin with, that means our E naught is 0. So then that means that if that's canceled out, that our work equals E final. But we just showed that we did W equals mgh to lift the barbell. So that means that if we replace this for W in this equation, mgh equals the E final. So the name for this form of energy is called gravitational potential energy, GPE, and that equals mgh. One important thing to know is while that changes in gravitational potential energy are important, their absolute value is not. So what they show here is 0 can be wherever you choose it to be. It could be the floor, measuring up to here, and that gives our height of 0.5. Or if we make this our 0 point and it goes up, that makes a height of 0.5. You have to pick where it starts at and call that 0. And you need to always be measuring for that. Another thing to remember is GPE equals mgh. It's the only energy that has height in it. So if you're ever given height, you know you need to start with that one. So what is the change of GPE for a 5 kilogram object? So our m equals 5, which is raised from the floor to a final height of 2 meters. So that means our h equals 2. So if we've got GPE equals mgh, and we plug in, we've got 5 times 9.8 times 2, we are going to get 98 joules. So an object falls, its GPE always blank. So if you think about a GPE equals mgh, if this number is going down, that means the height is going down, which means when they multiply, its answer is going to decrease because the number is going down. What is the change of GPE for an 8 kilogram object, so m equals 8 kilograms, which is lowered from an initial height of 2 meters above the floor to a final height of 1.5 meters above the floor? So that means our change in height is negative 0.5 because it goes down from 2 to 1.5. So it goes down by a half of a meter. So GPE equals mgh, and you plug in 8 times 9.8, times negative 0.5, and your GPE comes to 39.2 joules. What is the change in height? So now we're looking for h of a 2 kilogram object, so our m is 2, which gains 16 joules of GPE. So GPE equals mgh, and now to get our mg by itself, we're going to divide by, to get our h by itself, we're going to divide by mg to cancel them out. So now we've got h equals GPE over mg, which gives us 16 divided by 2 times 9.8. And our h equals 16 divided by 19.6, which gives us 0.82 meters. So that's it for this lesson. Make sure you have your packet filled out, and make sure you go on the Edmodo site and you put in what you learned or what you did not learn, and also put if you are red, yellow, or green.